Hello and welcome. Introduction. Now in this video, I'm going to show you how to interface and program a 4x3 keypad to an ATmega328p using the Arduino Uno R3 board. Construction of keypad. Now, in this part of the video, I would like to look into the construction of the 4x3 keypad. And here we have again the picture of the 4x3 keypad. And so this column here, I have called it, designated it as column 1. And this column here is column 2. And this column here is column 3. So I divided the keypad into column and rows. So this is row 1 and row 2, row 3, and row 4. And here we have the schematic version of the keypad. So this is column 1, column 2, column 3, row 1, row 2, row 3, and row 4. Before I go any further, I would like to mention these resistors here that are highlighted in orange. Now these are internal pull-up resistors in the ATmega328p microcontroller. As you can see, the keypad consists of 12 keys, from 0 to 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the additional keys are the hash key and the asterisk key. Now, so the keys are arranged in or organized in a matrix like this. And this part here are the terminals where the cables, the cable is. Notice the terminal labeling. So this is PD2, which is port D bit 2 of the ATmega328p. So this would be connected to port D bit 2, and this terminal will be connected to port D bit 3, and this would be connected to port D bit 4, and this is different here. This would be port B bit 0, and this is port D bit 7. This will be connected to port D bit 6, and this will be connected to port D bit 5. You may have observed that the missing bits are port D bit 0 and port D bit 1. I'll explain to you why that is. So here is the here is the Arduino Uno, and these pins here, pin 2, 3, 4, 5, 6, 7, they are port D bit. Starting with the pin 2, this would be port D bit 2 and all the way up to port D bit 7. And this would be port B bit 0. So pin 8 will be the port B bit 0 that I mentioned earlier. Now, as I mentioned earlier, port D bit 1 and port D bit 0 are missing from the earlier diagram because this would be port D bit 1 would be pin 1, port D bit 0 would be pin 0 of the Arduino Uno. Now, these two pins would be the serial transmission pin, one for transmit, the other one for receive. Now, as I have experienced earlier in my earlier videos, I do not want to interfere with this because that seemed to interfere with the uploading of the code if I use it. So I'm avoiding this two pins in this particular video. wiring. Now in this part of the video, I would like to show you how to connect the keypad, the 4x3 keypad, to the Arduino Uno R3. So first I would like to clarify how this schematic diagram, particularly these terminals, are related to the actual keypad cable connections. So PD2, that is port 2 bit 2, through to PD4, port D bit 4, they are related to these connections here on the keypad cable. And C1, which is column 1, that is connected to PD4. All right, so C1 is connected to PD4, is shown here. All right, and then C2, column 2, is connected to PD3, and that's C2 connected to PD3, and C3, that is column 3, is connected to PD2. Now the rows, and so row 1 is connected to PB0, port B bit 0, shown here as R1, and then row 2 is connected to port D bit 7, PD7, shown here as R2, and then R3, which is row 3, is connected to PD6, port D bit 6, and then R4, which is row 4, is connected to PD5, port D bit 5. Now here is the Arduino Uno R3, and I like to focus on this portion of the board, and I'm going to extract this out and zoom in. So, and I'm going to use this to show you how to connect it to the keypad. So first off, PB0, port B bit 0 of the connection here is connected to pin 8 on the Arduino Uno. And then PD5 connected to pin 5. PD6 is connected to pin 6. PD7 is connected to pin 7. PD4 is connected to pin 4. PD3 is connected to pin 3, and last but not least, PD2 connected to pin 2. Okay, so we've connected the keypad to the Arduino Uno R3 or the ATmega328p microcontroller. So let's look at how to scan the keypad using C. Now, before we can start scanning the keypad, we need to set up a few things. For example, the columns, the rows, and the pull-up resistor. So this part of the code, this portion here where my laser pointer is, now this part here will set up the column as input. Will set up the columns as inputs, and this part here will set up the rows as output. And then further down here we have these 3 lines of code, this block of code here that would enable the pull-up resistors at the relevant bits. All right, and then this here is to initialize the USART. Now that is because we are going to display the key pressed to the serial terminal. Okay, so before we get start scanning the keypad, we need to first of all set up the port to get it ready for the scanning. So remember, we're using port B and port D to connect the keypad to the ATmega328p. Now port B, although we're just using bit 0 for it, I'm going to set the entire port for the whole exercise, because we're not using port B for anything else. So now we could have I could have used the shift operator for this, which I will do later on, but for this particular part of the video, I'm going to use all 8 bits to set up the port B. And for port D, we are utilizing PD2, PD3, PD4, PD7, PD6, and PD5. All right, so we are also using this format to set up the entire port D, although we are not using all the entire 8 bits. Now I'm keeping this one here for consistency for this particular part of the video. Later on, I will ignore this one here. All right, so this is the setting up part of the keypad. All right, so now to scan the row. Let's look at row 1. To scan this row, we need to send this binary code to port B. All right, so we need to set this to port PB0 or port B bit 0 to a 0. All right, this would then scan the row. Now to scan column 1, we will or I will use this shift operator to scan this column, and also to check for key press. So this if statement here with the shift operator will do that, and if this key is pressed, all right, we will set this to 0, because this will complete the circuit. So this will be set to 0, and we then send the 3 to the serial terminal. This is how we will scan the column and check for a key press. Demonstration 1. Okay, so this is the ATmega Studio 7, and I've uploaded the code demonstrator here. So the first 3 lines are the include directives. This one is this is the io.h header file that contains all the definition of the things like DDRD, the registers, and so on. So these are all defined in the io.h. Now this define here determines the speed of the microcontroller, and the delay.h header file is because we're going to use the delay function in our code. Now these two functions that I declare here, and they are used to because I'm using the serial terminal to display the key press. So this first function here is to initialize the USAT, and this here is to send the key press to the terminal. Now I would not be going into the details of these how these two function works, because I have done a detailed explanation in my previous video on serial communication using C programming. So if you would like to refer to my previous video, you'll find all the details regarding this serial communication. And these two functions it's been defined here. All right, so this is the USAT init, and this is the USAT send. All right, so now before we scan the row and columns, we need to prepare or initialize certain registers. So here the first 3 lines here is to set the columns as inputs, All right, so we need to do this, and then we need to set the rows as outputs. So these are the code to do that. And then here we enable the pull-up resistors in the ATmega328p microcontroller. And then here is the function to call to initialize the USART. So we need to do this prior to scanning the rows and scanning the columns. So here, this is where we do the scanning the row. So basically, the first one we want to scan is row 1. So we need to set the least significant bit of port B to a 0. All right, and then we keep port D everything to a 1, so that will deactivate all the bits because we are only interested in scanning row 1. So these two instructions here or statements here basically is to do the row scan. Right, then to scan the column and to check for the key press, these are the code here. Now, for those of you who've been following my video series, you will know that this here is included to eliminate the what you call the switch bounce. All right, so I will demonstrate to you later on what will happen if we don't include this switch bound code. So basically, this part here will scan the column and to check for a key press. So basically, the whole piece of code here, here is to scan row 1 and scan column 1. That's all. We're not scanning the other 2 columns. We'll scan the other 2 columns in a later demonstration. All right, so okay. Oh, and there's one more thing. We are in this particular demonstration, we're only looking for a specific key in the column, that is key number 3. All right, so let me just like build the thing again. All right, so just to make sure, and then we upload the code. Okay. Right, so now that I've uploaded the code, I'm going to have the data visualizer connected. Watch out for this part here. Let me bring the camera back up again. So what I'm going to do is I'm going to, oh, by the way, we are just scanning this row 1, and scanning this column and looking and checking only specifically number 3, key number 3. All right, so watch out for the terminal here as I press 3. Yeah, I pressed it too long and I'm getting 2. So 2 3s. So do it again and again and again. All right, so that seems to be working. So we'll end the demonstration here. Scan row 1 and columns. Okay, so what I like to do here is to summarize what has been discussed so far. So we'll start scanning from the top again. So here we'll scan the row, which is row 1. All right, you scan row 1 here by setting this to 0. Right, because that would be PB0. That's connected to row 1. Then we scan the column 1. All right, so we've gone through this earlier. So and then we scan the column and we check for key press. If the key is pressed, then we send this to the serial terminal. Then we scan column 2 and then check for key press. Notice this is almost identical to the column 1. All right, the only difference is this shift operator here. Then we scan column 3 and check for key press. Again, notice the only difference here is the shift operator where we are looking for this particular key. And that's how you do the scan row 1, and then scan column 1, column 2, and then finally column 3. So let's take a look at the demonstration. Demonstration 2. Okay, so I've uploaded the code for the second demonstration here. As you can see, this here identical to the previous demonstration that we seen earlier. So I'm not going to go through this part again. So I'm going to go straight to the main function here. Let me just pull the right. So in the previous demonstration, we only scan wait a minute. Let me just scan. Right. We scan this row, and then we scan this column, and only checking for this key, number 3. But what we're going to do in this particular demonstration is that we'll scan this row, and then we will scan this column 1, then we'll scan column 2, and then we'll scan column 3, looking specifically only for 3 keys. The number 3, 2, and 1 keys. The rest we are not going to deal with it for the time for now. So we're going to scan row 1, then scan column 1, column 2, column 3, and checking for these 3 keys, 1, 2, and 3. All right, so there is these 2 lines here will activate row 1 or scan row 1, and then here this block of code here will scan column 1 and check for the number 3 key. Now if this is not pressed, if number 3 is not pressed, then it will move on, else it will move on to this block, scanning column 2, looking for number 2 key. And then if this is not pressed, then it was, and then else it will then scan column 3, looking for this key, number 1 key. And basically that's the function of the entire code. Here we initialize the whatever needs to be initialized. Here we then scan the row. There is row 1, then column 1, scan column 1, scan column 2, and then scan column 3 if no keys are pressed, and it will repeat itself over and over again. All right, if one of the keys is pressed, it will then be sent to the serial terminal. All right, so enough said. Let me just build the code. All right, so no issue, we've succeeded. Then I upload the code, and then put on the data visualizer, get connected. So watch this part here. All right, and then I will press 1. Wait, let me just bring up the camera. Let me just hold down this keypad. So 1, you can see 2 ones been displayed. That's because the bounce duration needs to be adjusted. Then 2, 3, and do again 3, 2, 1. All right. Let me just go back to this part here. I've included this extra delay here. It was supposed to give it a better debounce, what do you call, effect, debounce effect. But I think we need to adjust this, or you might want to adjust this to cater for the how you press the key. So I'll leave it up to you to experiment and find out what is the best value you need to put in here. Now, I'm sorry I can't give you a golden rule as to determine how to determine this value here. But if you care to experiment with it, you'll probably find a suitable recall value for yourself. Okay, so now you have seen how to scan a row and columns. So basically, you need to repeat the process with the other 3 rows. And why don't we just go through one more row? Let's do a row 2 scan and columns. So to scan row 2, because we're not using port B anymore, we set them all the bits to 1. Now for port D, row 2 is connected to PD7, port D bit 7. So we need to set this to 0. So that would then scan row 2. Now having done that, you proceed to scan column 1 and check for key press. And basically this shift operator, you may notice that it's the same as the one that we used in the previous row 1 scan. Now if 6 is pressed, then you send that to the serial terminal. Then you do a column 2 scan, paying attention to the shift operator here, and if 5 is pressed, it will then send it to the serial terminal. Then finally you do a column 3 scan, checking for key press, and then if this is pressed, and then you send this 4 to the serial terminal. And that's how you do a row scan and columns scan. Putting it together, now that we know how to scan rows and columns, let's put each row scan and each column scan into individual C function as shown here. So we have 4 rows, so we can have scan row 1, scan row 2, scan row 3, scan row 4. Then we, in the main function, we can put them in a while loop and then invoke or call them within the while loop. So again here we have scan row 1, scan row 2, scan row 3, scan row 4. Now here is an example of a one of those functions, and this is scan row 1, and basically this is identical to the code that we have discussed earlier. So these 2 instructions here basically that will do the row scan row 1. So make sure you activate the right bit. Now for row 1 we are using port B bit 0. So this is set to 0. Port D we're not using, so we leave them all at once in logic 1s, and then we have a short delay. And here, this block here, if you recognize it, that is the column scan and the key check All right, so we're checking for 3. Now, if this is pressed, then you send it to the serial terminal. Now, if 3 is not pressed, then you move on to the next column scan, checking for this key, number 2. If it's pressed, then you send that to the serial terminal. Now, if this is not activated or not pressed, then you move on to the next one where you do the column 3 scan, check for 1, and if it's pressed, then you send this one to the serial terminal. Demonstration 3. Okay, so this is ATmega Studio with my code which I uploaded earlier. So here, first 3 lines here are the include and define directives, and then followed by these 2 function declaration that will take care of the serial terminal. So this one will initialize the serial terminal. This one will send the key that is pressed to the serial terminal itself. And then here are the 4 functions that we discussed earlier. So this is scan row 1, scan row 2, scan row 3, scan row 4. And the details, the definition of these functions are here. So scan row 1, again, we have discussed this earlier. So here we'll just activate or scan row 1, and then a short delay, scan column 1, checking for this key, number 3. And if it's not pressed, you move on to the next, if it's pressed, then you send this to the serial terminal. If it's not pressed, you scan column 2, looking for this key. If it's pressed, you send it to the serial terminal. If it's not, you move on, else scan the next column, looking for this key, and so on. Now, the other rows are basically the same. Scan row 2, make sure you activate the right we call bit. In this case, is port D, bit 7. That will scan row 2. Then you do the column scan. If you notice, this column scan is almost identical to this one here, except for the key that you're looking for. All right. And then if this is not pressed, you move on to the next column, check for this key, number 5. If it's pressed, you send it to the terminal, and then scan column 3, looking for this key, and if it's pressed, you send it. And then column 3, basically the same, but make sure you activate the right bit to scan the row. And then finally column 4, again, make sure you activate the right bit to scan row 4. Then you scan column after column and the next column, looking for specific keys. All right, so basically that is the I've uploaded the code for you to experiment, to check it out. So in the main function here in the while loop, we keep calling this function, checking it. All right, so let's now compile the code. It succeeded, no problem. Let me upload the code to the Arduino Uno. Call the data visualizer. Get it connected. So we have terminal here, and call my camera up. So watch this terminal here. It should, let me hold down the keypad and press the asterisk key. All right, you should see an asterisk here. And then let me do number 3. Yep. And the hash key. And number 1. 7. 9, 6, 5, 5, 4, and 2. All right. So, and 0, sorry. Try it. 0, yep. So, all keys are working correctly. So, I think that's the end for this particular demonstration. Okay, that's it for this video. I hope you found the contents useful. Thank you for watching, and I'll see you in the next video. Bye!